So now let's use other techniques in algebra to solve these type of equations. And one of the first types we're going to use is the factoring patterns. And so when you see something like this, especially where you have the squared term of a function and then the function written individually like this, you can think of it as, remember, cosine is the x function. So we'll write this as 2x squared minus 7x plus 3. And it's set equal to 0. This is a classic factoring problem for us now. So we'll go ahead and factor it. So to factor this, however you factor, we're going to get our factors for this. I'm going to factor using a method like this. That's 2. So it'll be x squared minus 7x plus 6. So my factors are x minus 6, x minus 1 equals 0. I'll divide both of them by 2. So my factors are x minus 3 and 2x minus 1 equals 0. From here, I can go ahead and solve my equations by setting both these factors equal to 0, just like I would out of a factor and get solutions. And I would get solutions of x equals 3 or x equals 1/2. Now, here's a problem. Certain solutions, when you factor, may or may not be on the circle. And remember, we're talking about x. So we go back and replace x with its values. I'm talking cosine of, in this particular case, theta equals 3, or the cosine of theta equals 1/2. Well, the problem with that is this value right here never occurs on the circle. That problem never occurs on my circle. This problem, this right here, cosine theta equals 1/2, does occur. And so I want to find the values where the x's are 1/2 at. Well, they're 1/2 at pi over 3, and they're also 1/2 at 5 pi over 3. So theta is equal to pi over 3 plus 2 pi over n, and theta is also equal to 5 pi over 3 plus 2 pi over n. So when we do factoring, we have to be careful to make sure that our actual values pop up on the circle.